diseases. And of these people, some 400,000 are blind. And as the population increases and people live longer, we only expect this number to increase. We expect it to increase by 50% in the next 10 years alone. And sadly, we're still at a point where there are no options. There are no FDA-approved treatments, nothing they can do. Now, that's not to say that people aren't working on it. People have been working on it for centuries. Go back 250 years ago, Charles Leroy would apply electrical current to his patient's skull as a way to try to restore some visual perception. In one instance, he's recalling, in addition to provoking terrible cries due to the pain of the electrical current, the patient perceived a flame that rapidly descended before his eyes. Now, unfortunately, the next 100 years didn't really improve the technology very much. This is an image of Duchamp. He's on the right there, applying electrical current to his patient. The difference here is this person was actually sighted. What he's trying to do is induce blindness. It's a way of trying to understand how we see. Now fast forward another 100 years. This is Giles Brindley. He created the first implantable visual prosthesis. It would be implanted on the back of the head, on the occipital lobe, stimulating the visual cortex. He would do this to try to restore some visual sight. And unfortunately, this was the 1960s. The technology was still quite early, and it cost way too much to warrant the project drop. The eye is the first stage of seeing. Light enters through the cornea and the lens, hitting the retina, which consists of a series of different cell types, the photoreceptors, the bipolar cells, and ganglion cells. And so as light enters, it goes through the ganglion and bipolar cells, activating the photoreceptors, and this is exactly how we see. People that suffer from retinal degenerative diseases lose photoreceptors and simply have no way of capturing light. However, the bipolar cells and ganglion cells still remain. So the question is, what happens if we were able to make these cells light sensitive? Could we restore some functional vision? Through a massive collaboration here at USC, MIT, the University of Florida, and EOS Neuroscience, we are taking a gene that encodes a light-sensitive protein from an algae, introducing it into a virus. These are viruses that have been used in 36 different human clinical trials currently, and essentially create a gene therapy that allows cells to be light sensitive.